The objective for this video is to learn how to find probabilities associated with a normally distributed variable using the normal distribution table. Using the normal distribution table, find the probability that a randomly selected standardized value from a normally distributed variable is between -2.07 and 1.88. This can also be described as finding the area under the normal curve between 2.07 standard deviations to the left of the mean and 1.88 standard deviations to the right of the mean. The cumulative normal distribution table gives us probabilities associated with z-values. We are looking for the probability associated with the z-score -2.07. So we will find the entry in the table where the row -2.0 intersects with the column 0.07. We find this value to be 0.0192. We will also look for the value associated with the z-score 1.88. So we find the entry where the row labeled 1.8 intersects with the column labeled 0.08. That value is 0.9699. The graph at the bottom of the table shows that these 4 decimal place values in the body of the table correspond to the area under the curve that extends from the left tail up to the z-score. So the value 0.0192 would correspond to the area under the curve that extends from the left tail to the z-score -2.07. The value 0.9699 would correspond to the area under the curve that extends from the left tail to the z-score 1.88. But our requested probability calls for the area that extends from the z-score -2.07 up to the z-score 1.88. So the area that we are looking for is the difference between these values, which is 0.9507. In probability notation, we would write the probability that z is between -2.07 and 1.88 is equal to 0.9699 minus 0.0192, which is equal to 0.9507. In this video, we learned how to find probabilities associated with a normally distributed variable using the normal distribution table.